Today I wanted to make a short video welcoming everyone to iGold. In iGold we have a new store in Eilat where you can buy up to 3 ounces of gold and 100 ounces of silver per month per person. One of the questions customers ask us is how do we know the gold bars that we're purchasing from iGold are authentic? So iGold, we're the authorized distributor in Israel of PAM Swiss gold and silver coins and bars. And we're also the distributor of Sigma Metallic's precious metal tester. Here we have the investor device with us. Now, the way we check our gold, we do 4 tests. The first test, which is usually the one most fakes fail on, is the weight. So 1 ounce of gold, whether it's a gold coin, it's 31.1, or a silver coin, 31.1, or a gold bar, 31.1. What you'll notice is that all these products are the same weight, yet you will see they have different density. Gold is about 19 grams per cubic centimeter, and silver is about 10. So we will next move on to the Sigma device test. We'll place the gold underneath the sensor. There's 2 sensors, one underneath and one above. We've made the setting to pure gold. When we push down the sensor, the Sigma device will take a reading between the two sensors, and if it's inside the green, you know it's gold. If we take another metal like silver, the reading, and we're testing for pure gold, you'll see the arrow is in the red. This is not gold. It doesn't have the correct resistivity. Second, we're testing for the resistivity. That arrow should be in the green. And third, the Sigma device will take a thickness reading, 1.9 millimeters. We'll click measure. We'll press enter. And this is the density of, this will check the density of the coin. It will take the thickness of the coin and calculate how large the coin needs to be if it's gold. If this coin were made of gold and it looked like gold, how would you know it's not? Because its density is incorrect. Perhaps the weight is the same, perhaps the resistivity. They could add metals together and make a coin which passes the resistivity test, but the density wouldn't be correct. So what happens if all 3 of these tests fail? And we notice that there's a reading, maybe the gold reading is slightly in the yellow, and we're concerned. That comes to our 4th test. In iGold, we're registered with Sorek. We're allowed to operate an XRF device in Israel. And as you can see, here's our XRF device. It uses X-rays, which shoots at the metal. Here we take a gold coin, like a Britannia. We'll place it on the sensor. We only do this, it's an expensive machine, we only do it if there's a question about the authenticity of the gold. So our gold coin, our Britannia, is inside the protective casing of the XRF device. We seal it. Here is the XRF device. This green sign means the device is sealed and closed. And now we're going to run a batch test on the machine. So inside here is the coin, and it's a gold Britannia, so we expect it to be 24 karat. You can see it's not a gold plated coin. All that means is that the device will test the surface of the metal and maybe a few microns deep, just to check whether the product is gold plated. It's mostly for jewelry. Let's do a short test on a silver Britannia. Let's see if this is pure silver or not. Maybe all this time we have impure silver. So the silver's in the machine. We will run another batch, and we have 99.9% silver. So now we've taken our 2 coins out of the XRF device. I'm sure they're very happy to be out of the direct beam of the X-rays. And what's different with iGold is we now have the 2 readings of the gold and silver. So here you will see, first we did a test for gold and it came out to be 49 gold. And we did a test for silver. AG is silver. In this case it says 49 silver. And it's actually a 39 coin. You'll see 9999. And if we ran the test for longer, it would have dropped that 0.09%. But what's very interesting with iGold for customers, maybe even for jewelry companies, is that we're able to print a certificate. So we're able to print a certificate for every specific bar and be able to offer this service to customers. So here for AG, this customer's gold is 99.99 with an error rating of 1.52%. So scientifically, while the Sigma device will tell you whether a coin is authentic or not, a Sigma device is basically a binary device. It'll tell you this is a real coin, it's a fake coin. It's made of gold, it's not made of gold. The XRF device, on the other hand, it will tell you exactly what the coin is made of. So it'll tell you down to the exact percent.